Hello, myself T. Kaushik Reddy, and my roll number is 22951A0570, and I'm from CSCA. And my TikTok topic for machine learning is predicting heart diseases at early stages using machine learning, a survey. So let's get started with the introduction or anything which may be there in the next slide. So we'll start with an abstract, which is in the first slide, which includes the cardiovascular diseases diagnosis is the most difficult task in medicine. The diagnosis of heart disease is complicated because it requires the grouping of massive volumes of clinical and pathological data. As a result of dilemma, researchers and clinical professionals have developed a strong interest in efficient and exact prediction of heart disease. When it comes to heart disease, it is critical to obtain an accurate diagnosis at an early stage because time is of the essence. Heart diseases is the largest cause of death worldwide, and early detection of heart disease is critical. Machine learning has evolved as one of the most progressive, dependable, and supportive tools in the medical field in recent years, providing the greatest assistance for the disease prediction when properly trained and tested. The primary objective of this research is to evaluate several algorithms for heart disease prediction. Here is an introduction which heart disease remains one of the leading cause of death worldwide, with early detection playing a critical role in improving patient outcomes and reducing mortality mortality rates. Traditional diagnostics methods often involve invasive procedures, manual assessments, or are limited by human error and time constraints. As the volume of healthcare data continues to grow, there is an increasing demand for more efficient, accurate, and non-invasive techniques for predicting heart disease at its early stages. At its early stages. Machine learning, a subset of artificial intelligence, has emerged as a powerful tool for analyzing complex medical data and identifying patterns that may not be immediately apparent to clinicians. By training algorithms on historical patient data, including symptoms, medical history, and clinical test result, ML models can assist in the early diagnostic of heart conditions with high precision. These models not only support fast clinical decision making, but also help in personalizing treatment plans based on individual risk factors. This is a second slide for the introduction. And this is a third slide for the introduction, which includes this survey aims to provide a comprehensive overview of recent advancements in applying machine learning techniques for early stage heart disease prediction. It explores the types of algorithms used, the nature of data sets involved, key performance metrics, and the challenges faced in practical implementation. Though the study highlights the growing potential of ML-driven healthcare solutions to enhance diagnostic accuracy, reduce healthcare costs, and ultimately save lives. So this is the image which includes the clinical data, which down the flow chart, which after the clinical data, which includes data pre-processing, then the feature selection, then the feature extraction, then the cluster-based oversample method, then the classification. In the classification, we have two. That is, first one is the heart disease present and heart disease absent, which tells whole process tells whether the heart disease present or not. Yeah, then the key standards, data quality and pre-processing standards. One of the foundational standards in the heart disease prediction using machine learning is quality and pre-processing of medical data. Accurate prediction rely on well-structured data sets that include relevant patient prediction, rely on well-structured data sets that include relevant patient attributes such as age, blood pressure, cholesterol levels, heart rate, and ECG results. Standard pricing practices involve cleaning missing or inconsistent values, normalization of features, and balancing class distributions to reduce bias. These pre-processing steps ensure that machine learning models are trained on reliable and meaningful inputs, enhancing both accuracy and generalizability. Generalizability. Then model selection and evaluation metrics. This is another key standard. Choosing the right model in crucial in early heart disease detection. Sorry, choosing the right model is crucial in early disease detection. Commonly used algorithms include logistic regression, decision tree, random forest, support vector machine, and deep learning models like neural networks. Standard evaluation metrics such as accuracy, precision, recall, F1 score, and AUC ROC are com- essential to compare and validate the performance of different models. The selection of a model is typically guided by its ability to handle imbalanced datasets, interpretability, and computational efficiency, especially in clinical or real-time diagnostic settings. Ethical interpretability and deployment standards. In medical applications, ethical standards and model interpretability are paramount. Models must not only be accurate, but also transparent to gain the trust of healthcare professionals. Techniques like sharp values or lime help interpret predictions, explaining how features influence decisions. Data privacy and security, especially under standards like HIPAA or GDPR, are also critical during deployment. Furthermore, real-world applications demand model that integrate seamlessly with existing health information systems and provide actionable insights without overwhelming clinicians. So this is the introduction. In the introduction, we have three parts. That is motivation and paper contribution, and is a paper selection strategy and the organization of the paper. And then the role of second is the role of machine learning in cardiovascular disease prediction, which includes the background and the significance of feature selection in cardiovascular disease prediction and related state of the art research. Machine learning models for cardiovascular disease prediction and related state of the art research. Data collection and pre-processing, which includes the data collection and data pre-processing techniques. And in evaluation metrics and cross-validation for cardiovascular disease prediction. Includes 5.1 includes evaluation metrics, and 5.2 is model validation and cross-validation, and 5.3 is model interpretability and explainability. And the last sixth is the recent trends in machine learning for cardiovascular disease prediction and future works. And the seven is the conclusion. Data processing standards. Data pre-processing standards. Data pre-processing is essential for accurate heart disease prediction using machine learning. Missing values are handled using mean, median, or KNN-based. KNN is k-nearest neighbor. Imputation to maintain data quality. Categorical features like chest pain and sex are encoded using label or one-hot encoding. Feature scaling techniques such as min, max, normalization, and Z-score standardization ensure uniform data ranges. Outliers are detected using IQR or Z-score methods to avoid skewed results. Feature selection through correlation analysis, or RFE reduces dimensionality. Class selection through correlation analysis, or RFE reduced dimensionality. Class imbalance is managed using oversampling SMOT, the SMOT, or undersampling techniques. Stratified data splitting is used to preserve class distribution across training and test sets. These standards improve model accuracy, reduce bias, and ensure clinical relevance. Proper pre-processing builds the foundation for trustworthy and efficient heart disease prediction system. So machine learning models used. Various machine learning models have been employed to predict heart diseases at early stages, each offering distinct strengths. Logistic regression is widely used for its simplicity and interpretability in binary classification tasks. Decision trees and random forests handle nonlinear relationship and feature importance effectively. support vector machines, provide robust performance and high dimensional data. K-nearest neighbor is intuitive and effective for smaller data sets. Naive Bayes is used for its speed and work well with categorical data. Gradient boosting models such as XGBoost often achieve high accuracy. Artificial neural networks and deep learning approaches are used for complex pattern recognition in large datasets. Model performance is typically evaluated using accuracy, precision, recall, FN score, and AUC. Choosing the right model depends on the dataset size, feature types, and the need for interpretability. Real world integration of machine learning models for heart disease predictions requires seamless alignment with existing healthcare system. Models must be compatible with electronic health record systems to access real-time patient data. Deployment on cloud platforms or edge devices allow remote and continuous monitoring, especially in rural or low resource settling. User-friendly doctor dashboards and mobile health apps help present predictions clearly and support clinical decision making. Interoperability with medical devices like ECG monitors improves data flow, ensuring data privacy and compliance. Real-time alerts can prompt early intervention, reducing critical outcomes. Continuous model retraining with new data improves adaptability. Ultimately, integration focuses on accuracy, accessibility, and clinical usability. So these are the challenges and the feature scope, which include despite promising results, several challenges hinder the widespread adoption of the machine learning in hard disease prediction. This include the limited availability of high labeled labeled medical data, class imbalance, and privacy concerns, and limited clinical trust. Integrating ML systems into hospital workflows remain complex due to lack of standardization. In the future, improved data sharing frameworks, federated learning, and privacy preserving algorithms can help address these barriers. Research into explainable AI will enhance the transparency adoption, development of personalized models using genomics and lifestyle data is growing area. And the conclusion, machine learning has a show significant potential in predicting heart disease as early stages by analyzing medical data efficiently and accurately with proper data pre-processing models, selection and evaluation. ML system can assist in time diagnosis and preventive care. The use of various algorithms from logistic regression to deep learning provides flexible options based on clinical needs and data complexity. Real-world integration of these models into healthcare systems, wearable and mobile applications is steadily improving. However, challenges such as data quality, interpretability, and regularity components remain. Addressing this will be essential for broader adoption. Their future lies in building ethical, transparent, and scalable solutions. With continuous advancements, machine learning can revolutionize cardiovascular healthcare and save countless lives through early intervention and informed decision making. So yeah, thank you. This is my PPT, AAT Tech Talk for machine learning.